Molasses in January, to be specific. All right, so we today are talking about some new sampling methods. Now, so this thing says systematic, right? I can choose a sample from a population using a systematic or a random method. What does it mean if you are systematic? If you say like, man, Mrs. Cullen is a really great teacher. She's really systematic with everything she does. What would that mean? Zach, what do you think?
She has a system and she follows it.
What do you mean has a system? What does that mean to have a system?
Like it's, let's say, you have like every day right before you leave school, you like organize your binder or whatever.
Yeah, there's like something that you do over and over again, right? Like a system is like a guiding rule or a guiding principle. What does it mean if I say Mr. Estes is really random? I never know what he's going to do. Well, okay, so yeah, it's true, but she...
that you don't know what he's, like may have like multiple things to do.
What's another synonym for random? No? Unpredictable. So random is something that can't be predicted. There's no method to determine it. It's just completely random. There's no way to decide who would get chosen. So you're in gym. Your gym teacher said, line up, we're going to play dodgeball or play something. Mat ball's really my favorite. And your gym teacher lines up the class and starts picking every third person to make up a team. Would that be a system or a random? Or not? Or
Would be a system.
Yeah. There's a rule. So this is a system or a systematic way to choose people because every third person is like a guiding rule that tells me what to do. Now, what would be a benefit to using a system to make your choices? What would be a benefit to using a system?
It's quick.
Yeah, it's quick, right? I know who I'm going to choose, and I'm not really making the choices. I'm just doing what the system told me to do. So I don't have to worry about you guys getting upset with me. I'm choosing every third person. I didn't make these choices. Any other benefits? Is it easy to choose every third person?
Yeah.
Yeah. So now it's quick and it's easy. Are there any drawbacks? Right?
You might not have an even amount of each.
Yeah, you may end up with some like uneven teams, but if we're just choosing like a sample, like we're doing the data collection, that wouldn't really matter. But I agree, if you're choosing teams, that would matter. Zach?
So like in gym, this sometimes happens if you're like near the back of the line. You like see the pattern that they're doing, so like you'll like arrange yourself so you're with someone.
It's anticipatable, right? You can anticipate what's going to happen and who's going to get chosen. So I start saying, okay, Team A, Team B. Team A, Team B. Team A. Yeah, Peyton's like, oh crap, I'm right beside Ella. I don't want to be because I want to be on her team. So when you can anticipate what's going to happen, the population can change things. So here's the problem. If there's a pattern in the population and I use a system, that pattern is going to get picked up by my systematic selection. So if I tell you to line up boy, girl, and then I choose every other person, I'm going to choose all boys or all girls. That's a really bad, I just essentially made my sample what I wanted it to be. But if I tell you to line up boy, girl, and then I choose every third person, I'd end up with a boy and a girl and a boy and a girl, and that would alternate then.
In gym, in like Friday gyms, when every 8th graders and 7th graders day.
Yeah.
Everybody, because we usually just play team games.
Mm-hmm.
And so everybody when she says I'm gonna be counting by 4, everybody starts moving around.
They're doing their quick math.
spreading out.
She tells us what she's gonna do.
And then she waits for she anticipates us anticipating what she's gonna do.
Yeah.
So she just waits for us to stop moving and then starts moving.
She.
But with Mr. Estes and Mr. Camilo, when we're picking teams for the science thing,
Yeah.
they just go all over the place, and you don't really know who they're choosing.
So do you think they're systematic or do you think they're random?
Random.
They're random, right? Because if I don't want you to be able to anticipate, I'm going to choose you guys at random. Peyton?
With teams, like in gym, skill level can get messed up. So
Yeah.
like if you might end up with a team that's really strong in one area with another team that can't play.
Yeah, so we'll talk about how we can compensate for that. If we know that there's like a really high skill set and then lower skill sets, we can make some choices with how we collect our data to compensate for that. So, systematic is really easy. For your definition, so here's your notes, right? Systematic sample, all you need to write here is, so you could put a sampling method where we choose every nth person. N just represents a number. N is our variable. It's a placeholder right now. It represents a number. So, to find that N, over here below your people, write out N equals, how do we find that N? We're going to take our population size over the size of the sample that we want. So we're going to take the population size over the sample that we want. So the first thing we have to know, how big is our population? So I can count up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Now we have 20 people in our population. What do you think a decent sample size would be? Shahid?
4.
Sure, you do 4. So that comes out to give me 5. So that now creates my rule of choose every 5th person.
Wait, how do we get 4 again?
That's the sample size that Shahid told me I want. So we've determined we want
Oh, so
4
it's just
people in our sample.
Okay.
So my sample will end up being 4 big. So the place where most people like make a mistake, well, not really a mistake because this doesn't really mess up your data. Where do I start? Well, I'm choosing every 5th person. There's only one minor rule for where I start. Nate?
Wait. Wouldn't you just like count 1, 2, 3, 4, 5 and then start it over?
Start at the beginning.
Yeah.
Both of you are right.
Okay.
So could I start with the first person in the group?
Yeah.
Yeah, so if I did, I've chosen this person. So then 1, 2, 3, 4, 5. I choose this person. 1, 2, 3, 4. So I can do that, right? Could I choose to start with the second person?
Yeah. No, wait, yeah.
Yeah, because I choose that person. 1, 2, 3, 4, 5. I choose that person. 1, 2, 3, 4, 5. I choose that person. Could I start with the third?
Sure.
If I shift that one, then I shift this one, and then I shift this one. Could I start with the fourth?
Sure.
Could I start with the fifth?
Yeah.
Could I start with the sixth?
No.
So, where you start has to be under, or at or under, so less than or equal to, your n. So my start point will be at 5 or below. My start point will be at 5 or below because of this 5 right here. Now, if I was choosing every 4th person, I'd have to start at 4 or below. If I was choosing every 3rd person, I'd have to start at 3 or below. So really, you're starting at n or below. If you want to notate that, it's just whatever your n value is, you start there or below. And it doesn't matter who you start with, you just choose that randomly. So decide where you're going to start and choose your sample up here. So you can start with person 1, 2, 3, 4, or 5. Circle all the people that are going to be in your sample. I'm going to start with person 3 just because. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I got my sample of 4 people. Your sample may not be yeah, because I'm choosing every 5th to make a sample of 4. So this is your sample size on bottom here. I don't notice anything about my sample. It's a parallelogram, yes. Jackson?
When the however you start away from the beginning is the exact same at the end.
Not necessarily, because if I started at person 4, then each of these would shift, and I'd end up with 1 at the end. But when I started, well, so even if I shift all of mine and I start at 4 now, I still have a problem. No? Okay, Nate.
Is it all the people, or 2 people are different?
What do you mean 2 of the people are different?
Like they're different colors.
Peyton?
There's no green people.
There's no green people! Are there green people in my population?
Sure.
Say that 10 times fast. Green people in your population. Are there green people in my sample? No. If I go back to what I had originally, start with the 3rd person.
But now there's no
Now there's
purple.
no purple people. Or purple people either. So this ends up biased. Although this is an acceptable sampling method, we can end up with a biased sample.
What if we choose like every other?
We could play around with that until we figure out like what would give me a representative sample. Because Pranav just asked, what if we choose every other? So we could try that and see, do I get a representative sample then?
Mr. Esson,
Yeah.
If you do 1, if you start at the 1st person, I think you do.
Yeah. We could play with that for a little while. We're going to keep moving on now. So suppose we're doing research on the students at your school. Determine, is this a systematic sampling method? If not, what is it? What do you think it is? So we learned about convenience yesterday. We talked a little bit about random right now, and we're going to hopefully get to that maybe. Let's say I'm texting with the treasurer of the PTSA,
Who is that?
the person who handles the money.
Well, I know. It's like who?
I wish. Here, I don't need you. All right, you make a list of students in your class and choose every 7th name starting from the 1st name. Pranav, what do you think? Is that systematic?
Yeah.
Yes. And actually, I'm going to write systematic because for the other ones, we might write what they are. Because every 7th name, every n terms, their n is just my 7th. Grace, if you have the students in your class count off by 4s, and you choose every person who counted a 3. It is systematic, and there, my n is 4 because we counted by 4s. Rye, what about if you make a list of students and choose the first 10 names on your list?
No, that's what we did yesterday, isn't it?
So that, it's convenient to make the choice, but if they're just names on your list, will they necessarily be available? No, so that one is close to a convenient sample, but it's still not.
What?
So that one so
I wasn't here.
first 10 names on your list, right? This is why you should have watched the video.
Yeah.
A convenient sample is defined by being easy, what convenient means, and available. They have to be available for you to collect that data. If you're choosing names off a list, you might have to go get those people. They're not currently available. If I choose you 5 people on the front row, you're convenient for me and you're available right now. So that would be a convenient sample. This is halfway to a convenient sample, but not quite. No?
Doesn't it matter how the names are organized? Because if they're like in alphabetical order, isn't that systematic? You just pick the next alphabet.
To be systematic, you have to be choosing every nth term. There has to be a number gap that stays like constant. So yeah, so when you choose the first 10, that's not a system. So try to got it on your own. You're determining, is each of the sampling methods they used systematic? If not, see if you can define it in one of the other methods that we have. Movie theater wants to survey customers, make sure they are maintaining a customer-friendly environment. Oh. I always trick myself into thinking this class is done before it is. I was just thinking like, man, there's no way we're going to get through both lessons. We'll do it. We got plenty of time. All right, Carrie. You ask every moviegoer, I always think goer is a weird word. You ask every moviegoer that walks into the theater. Is that systematic? No. Because that's not even a sampling method. Instead of collecting a sample, what would you have collected? The entire population. So you ask every single person, that is not even collecting a sample. Ashton, you choose one customer that comes into the theater.
It's not systematic, it's convenient. Because you're available and it's easy.
Yeah, but would that give you a convenient sample? Well, it would give you a convenient... I agree that that's convenient, but did you get a sample?
Oh, you get a subject.
You only get a subject. You don't get a sample. You end up with only one subject. Olivia, starting with the first moviegoer, you now choose every 5th moviegoer that comes into the theater. What is that? That is systematic with our N being equal to 5 because we're choosing every 5th moviegoer. And James, you select the first 20 customers that walk into your theater. What is it?
That's just normal sample.
Ooh, it's easier than that. If it's the first 20 and you are right there, that's a convenience sample. Seth, your card's up. Hopefully you feel better soon. Did you guys plan this that you were out yesterday and Seth's out today?
No, he says. All right, so he says he has this like acute something-itis, and it's like the number one symptom of bubonic plague.
Did he say he has bronchitis?
No. It's like severe swelling of lymph nodes.
Oh, yeah, that happens when you get sick. That probably has nothing to do with the bubonic plague. It probably just has to do with the fact that he's sick.
Okay.
Your lymph nodes swell up when you're sick. Similarities and differences between convenience and systematic. I'm just going to show them to you because it's easier that way. So check this out for a second. Do they both produce a sample? Yes, that's the whole point. Does it give you a representative sample? No, for your convenience. You'll pretty much always have some kind of bias. If the population does not have a pattern Then systematic gives you a representative sample. Do I have to know the population size? Convenient sample? No, I just pick the first however many I want. Systematic, I gotta know how big the population is. Requires picking numbers at random. The first number we pick in the systematic sample, we have to choose at random. And even when you make the choice in your head, that's like choosing it at random, unless you're saying I'm always gonna choose 2. And then that's not a random choice. And they both do require time and effort, but convenience requires a lot less. So, because somebody's like, well, what do you mean no, it doesn't require time? Okay, it requires some time, but very little time and effort. Questions? Sheep?
But with convenience sampling, couldn't you just like walking isn't really like walking to somebody wouldn't really be like yeah, it's easy. So would it I just thought about this. Like you pick people out of a hat and they're like somewhere else, and you just like walk to them.
Yeah, but that wasn't convenient for you. You had to go there. So when we talk about convenient, I want to put in like no work. I'm going to say, hey Shahib, what's your favorite video game? And you're right here available. Instead of me saying, hey, where's Shahib? I got to track you down. I got to go find you, and then I got to ask you the question.
And then you gotta come all the way back down.
Yeah, and then I got to come back and find my next person.
Write it down.
So again, a reminder of how we find that n, my gap between the terms. Take your population size over your sample size. If I was you, I would probably highlight this to remind you that this is how we find our interval. So, would this produce a representative sample?
Yeah.
Would this produce a representative sample? Now, I forget if showing you what's on here has anything to do with whether or not it is. Because then we can see the bookshelves. So, books don't appear to be in any specific, they're probably Dewey Decimal System or something like that. But if we choose every 8th book, like our notes are telling us, would that produce a representative sample? What do you think? Zach? What do you think? Would that produce a representative sample?
In the science section only?
Yep, so you are collecting data on how often the books are checked out. So the science books specifically. And you choose every 8th book and look at how often it was checked out.
I guess, kind of. I mean, isn't there some, problems with it because you can, it's chance?
So I agree that there could be problems with it. The big thing I think about was, what if I was collecting data on what the books are about, or things like that? That would have a pattern in the library because books are shelved by topic, or by author, depending. But if I'm just looking at how often the books are checked out, I don't think every 8th book is going to produce any kind of bias. I just choose every 8th book and I look at how often it was checked out. So because of the question that we're asking, we would assume that this does not produce a bias. It would likely be representative. Yeah, this is systematic. We chose our interval. We randomly choose a start point, and then we assume that it's probably representative because of the data that I'm actually asking about. So we want to determine how many students in your grade have a dream about flying. Always freaky if you hit the ground and you wake up, you think you died.
I keep having dreams where, immediately when I fall asleep, I trip.
So, while I go back and capture that part that didn't capture, I want you guys to describe how you make a sample of 20 students. How would you get a sample of 20 students? How would you get a sample of 20 students? You have to use a systematic approach. .340 students total in your school. You want your sample to be 20 Peyton, what math do I have to do? Yeah, you're going to take, to find your n, or your interval, you take the population over the sample. What can I do with stacked zeros? Get rid of them. So I really have 34 over 2, which comes out to be 17. So I'm going to choose every 17th student. Does this make sense to you guys?
Yes.
The only last thing I care for us to check out, when might a systematic sample not be representative? When there's a pattern. So the example, if you want to look at when we have a pattern, you can check out the Christmas lights problem. Christmas lights obviously come in a pattern. Red, yellow, green, blue, purple, red, yellow, green, blue, purple, red, yellow, green, blue, purple. So if I tried to take a systematic sample of Christmas lights, I will often get a biased sample because of that pattern. If I chose every 5th light, I'd keep getting the same light over and over again. So that's what we would have done here, but we're going to jump on to our simple random sampling. Not the one I want. You are here. Simple random is really the best, most fair sampling method. Why would that be? Why would simple random in any situation be the most fair sampling method? Jackson?
It would be the most fair because it's not like systematic where there's a pattern in how you're doing it. It's random, so no one gets, like, it's just random.
Yeah, there's like no preference in how you're picking people. It's just random. Peyton?
It's not biased.
Yeah, there shouldn't be a bias. We can't always definitively say it's not biased. How I'm choosing my people is not biased. My sample shouldn't have a bias. And even if it does, that happened randomly. So if my sample has a bias, my population probably has a bias. So, simple random sampling, our definition, really, and you're going to laugh at this probably, what we put for our definition, actually we'll say pick names. I don't necessarily like the word draw.
Why?
Pick names and then quotation out of a hat.
Oh, that's funny.
You've probably heard that, I'm not trying to be funny, you've probably heard that before, like draw names out of a hat. That's because back in the older days, most people had a hat on, most men, to protect their head, and you don't really want to go into the details of why they wore hats to protect their heads, because there was no modern sewage system, so you can go ahead and fill in the blanks if you want. So, when they were trying to select people, they'd say, okay, everybody write your name down on a slip of paper, put your names in this hat, and we'll mix them around and draw names at random, so that nobody could say there was preferential treatment. Everybody's watching me, I mixed up these names, and I didn't look, I drew it at random. So that's why they started saying draw names out of a hat, because that's literally what they would do. But in order to do this, we either have to have the names put into a hat, but what if I don't know everyone's names? What if I say, I want to collect data on Worthington students? What?
You could number them.
I could use numbering to use that. Now, how do I randomly pick numbers?
Computer.
My favorite website for random information or random data is literally random.org. It's a website called random.org. So, here's what I would do for this situation specifically. These people I would number and find out how many I have. So everyone number your people. We got to find out how many are in the population.
Do you number them randomly?
Well, you start at 1 and work your way up.
I didn't
But
get chapter 15-5.
were you at the restroom or something?
Yeah.
My bad. Hey, so they have to be sequential. You can't leave gaps in your numbers.
Keep going, it's okay. I'm just asking.
17.
Do not number the researcher. The researcher is not going to ask himself a question. That would be completely biased. He's the one collecting the research, so he does not get numbered. You should find out that there are 20 people here. So then once I know that there's 20 people, I go to random.org. I say, all right, I start at 1. I go to 20. Let's generate some numbers and pick some people. So circle your person 15. Circle your person 3. Circle your person, 3 again. So can I choose that person again? No, so we just randomly generate another number, 14. We randomly generate another 7. And let's stop with 5 people. We'll randomly generate one more, person 9. You want one more? All right. 1. So we had person 3, person 7. What else? Person 15 and person 14. And person 9. And then 1. Yeah, if you use that other one that I generated for Zach. So, is this representative? There's no blue people represented. So, the way that you can make your simple random become representative, make your sample bigger. Generate more numbers. So 15, we already have it. 20, let's go add 20 to our sample. Person 20, oop, now I have a blue person. I could stop there. If you still don't have a blue person, you can randomly generate more. So, generate another, we get 6. So you can keep making your sample bigger until it is representative, or you just stop and you say, I'm using this sample, whatever I have, I have. Sheep?
So what you're saying pretty much is the more you pull out of the hat, the more
Representative it is. Yeah. So the bigger your sample, you would assume the more representative it is. Because think about it. The closer you get to choosing every person, the closer you get to representing every person. So the bigger your sample, the more representative it becomes. But in simple random. Not with those other sampling methods because there's rules to determine what we're doing. Capture. Apparently all I have to do is yell at it. Alright, so do you think this is simple random sampling? Nate, you make an alphabetical list of your students in your class and you select the first 10 names.
Yes.
Is selecting the first 10 people random?
No.
No, the first 10 people, and Nate doesn't know this because he hasn't watched the video yet. What kind of sample is that? Convenience. Ooh, yeah. So it's like kind of convenient, kind of not, because it's a list of people. So then if they're here, say I have a list of you guys, a list of the people here with me, then it's convenience. But if the people aren't with me, then it's not. So we'll just say it's not random.
Yeah, it isn't random because you already pretty much know.
Okay, what about C?
It's predictable. That's why
We're gonna get there.
systematic, right?
Karen, what if I mix all the students' names in a hat and select 10 names all blindfolded? Yeah, that's random. Noah, what if I assign a number starting from 1 to each student in your class, then pick 10 of those numbers at random?
What number does it go to?
We just go up with integers until I get to the last person.
Yeah, that's random.
Yeah, this is random
So we just did.
because that's exactly what we just did. And it says at random. Yeah, you're choosing your numbers at random. So now this gets a little tricky because now we're going to be a botanist. You've gone to college, you found out that you are in love with plants. It's okay, I won't judge you. I love plants too. I am anxiously awaiting my tomatoes and peppers that I ordered from the plant sale. Did I order from you, Zach, or who did I order from? I don't know, but I'll get them hopefully. I ordered from Ethan. How do you know and I don't? It's weird. Alright, so we are now doing research on flowers. We go to a field of red, let's say, carnations. somebody has planted red carnations in this field. But over time, plants will like morph, they'll hybrid, they'll kind of like merge in with whatever surrounding they have. Sometimes the soil acidity changes the color. Literally, you can put different stuff into the soil and change the color of plants. You can do that with hydrangeas. So this field is supposed to be red flowers, but the owner has realized, I've got some pink flowers happening. So he calls you out to collect some data. So you have a few different sampling methods that you offer up, and you want to choose a simple random to try to get some fair data. So you choose every 10th flower in the field, starting with the 3rd flower. Lily, what kind of sampling method is that?
It's systematic.
Yep, it is systematic because you're choosing every 10th, and you started under 10. Since you started with the 3rd, you were under 10, and you chose every 10. Jackson, if you choose 3 flowers from the field,
Random.
do we know how they chose them?
No.
If I reach down and pick 3 flowers right next to each other, that's convenience. But if I walk around the field and choose 3 random flowers, that's random. Do we know how they chose the flowers? So we don't know. We don't have enough info. So you could put not enough info. We used to, when I was in math, label that NEI, not enough information. So if you want to label like that, if you can remember, we don't know enough. And 3 flowers, that's not a very big sample. That would not be a very good sample size. Yeah, out of a field full of flowers. You could have a field that's only this big, and you could have thousands of flowers, like depending on how tightly they're growing. You choose the 50 flowers closest to you. Ella, what kind of sample is that? 50 closest to you. Yeah, it's convenience. And Noah, you choose 50 flowers from different locations in the field.
That's random.
Yep, this is random. Now, I love when people in previous years have asked, now wait a minute, I thought to do a simple random you had to assign numbers and then choose numbers. If you were a researcher, would you assign a number to every flower? No, that'd be work that does not make any sense to do. So you could just walk over here, pick a flower, walk over there, pick a flower, but you'd want to make sure that how you pick the flowers, you're not looking at color. So maybe you put on a blindfold and walk around and pick 50 flowers. Maybe you tell somebody to go pick your 50 flowers and they don't know why they're picking flowers. So then they wouldn't have a bias because they don't know what you're studying. Maybe they think you're studying number of petals when actually you're studying color, or height when you're actually studying color.
It depends on who it is, though.
Right, so
Because
it has to be chosen at random. It has to not have a bias in your choices.
They could have a preference of pink over red or vice versa.
Exactly, so you'd have to make sure you get rid of the bias somehow. But that is random because it's different locations in the field. Yeah.
Going back to this problem, like the flowers changing colors.
Yeah.
At Wrigley Field in Chicago, the ivy on the wall changes colors because the bricks that are on the wall are from different places.
Nice. Yeah, so they're absorbing
So like there are patches of green, like it's all healthy because like they take really good care of it. But some of the leaves are like brownish green. So because the bricks yeah, like dyed intestinal.
Oh, I went too far. So real quick, some similarities, some differences. Shahid, what do you got for me?
So, if you were to put food coloring in dirt and you planted a flower, would it change?
I do not think so. You could try it, be an interesting science fair experiment, but I do not think that would matter. And actually, you'd probably be better off to put food coloring in the water that you're using to water the plants, because then it'll absorb it. The question is, will the food coloring matter when the plant absorbs it? When it absorbs certain chemicals, like whether they're natural or not natural chemicals, that affects the plant. But I don't know if food coloring would. Be interesting to try. Zach?
So like there's this cool experiment that some guy did, I forget who, but what he did was he got like 6 different little dishes of
Yeah.
like sugar water,
Okay.
and then he put different food coloring in each one,
Right.
and they would change color based on which one.
That's pretty cool. So do you guys think you understand what a simple random sample is and you can determine with the difference between the types? So here's the plan. Give me your ears still for 10 more seconds. Plan is tomorrow to finish the chapter and hopefully take the mastery, at least start the mastery on Friday. So we can talk tomorrow whether we actually want to start the mastery Friday or start the next chapter and wait for the mastery. So we'll figure that out tomorrow. We'll figure that out tomorrow so we can have a discussion then. Have a great day, guys. Yeah, it is. It's a fairly easy mastery. If you want a systematic sample of 10 people from this population, the hardest part is just remembering which is which and keeping them straight in your head.